Hello and welcome back to my channel. Over the weekend we had the inaugural case of the Microsoft Excel World Championship UK chapter, and this case was titled "At Liverpool Street Bus Station, Nobody Can Hear You Scream." A really fun case by Harry Watson. It centers around the London bus system. So you can see here on the banner, you have the classic red double-decker bus that happens to go to Liverpool Street. I would say that this was a really fun round, a really successful round for me. And so I am hoping to replicate that success and even take it a step further and get a full solve out here within 30 minutes. Let me just show you a little bit of what the case is about. If you want to see the introduction video, I will have it linked in the description. But basically, we have a lot of questions about the buses and the bus schedule and things like that. Some of the data that we have include a list of the omnibuses from Liverpool Street, so the time, bus number, destination. Does it turn up? This will happen. This will show up in one of the levels, and the duration of the journey. We have a list of postcodes here. So the area, borough, and the postcode, which is very interesting. I actually will admit I did struggle a little bit with this one, but I think it was mostly because I'm not that familiar with UK postcodes. And then we have a list of locations and a grid reference. We have this TQ number. So this is going to be exciting. Let's go ahead and give this another shot. Let's see if I can get a complete solve for you in 30 minutes. And here we go. So level 1 is asking us to extract the number from the front of this text. And we see the number precedes the text and there's a space in between it. So what we're going to do is we're going to take the text before the space in each of these cells. That will get us the number for the buses. For level 2, we have 3 bus numbers and we are asked to find the range, the difference between the largest and the smallest number of these 3 buses. So what I'm going to do is I'm going to create a variable called buses, and I'm going to take these 3 numbers, which are separated by a semicolon, and use that for my numbers for the buses here. Now what I'm expecting is that all 3 numbers will appear, which did not happen at first. And so I am just going to run through my formula to get all 3 numbers appeared before I get to the next step. Now you see what I'm doing is I'm multiplying by 1. That's because the text split function, as a text manipulation function, always outputs its results as text. We want to do math, so we need them to come out as numbers, then the max and min form functions will work. Bus 3, we are given a time and we are asked that where is the bus at that time going. So you can see the bus at 1557 is going to Kenley. I'm going to do an XLOOKUP here to look up the time in column A and to return the destination in column C. Now what you may have noticed is that when I click the letters A or C, it's going to highlight the entire table because the top row has merged cells. So once I copy all of the answers in, I'm going to go through all of these tabs and unmerge these cells. This will make referencing the entire columns on the sheet much easier. Level 4, we have a postcode and we are asked what time does the first bus scheduled to go there. So when I was doing this case, I mentioned this one I struggled with because I wasn't sure how the postcode related to areas and boroughs in this case. It turns out that the boroughs aren't absolutely necessary. I can simply highlight the area, do an XLOOKUP, return the postcode, and that will get me the postcode for all of the buses, all of the times. So now I'm going to look up the postcode. I'm going to look this up in column F, which I've created, return the time in column A, and that should give me the first time for all of the postcodes on this list. Level 5 asks us how many buses are scheduled to depart in each hour. So in the example, we are given hour 13, and we want to see all of the buses that are scheduled to depart in hour 13. Now, when I did this at first, what I tried to do was I tried to write in a count if statement to count all of the times that start with the numbers 1, 3. It turns out that the COUNTIF statement does not take an array. So you see I'm trying to do this left function in here. That turns the data from a range into an array, and the COUNTIF statement did not like an array to be the first argument. So this did not actually work. What I did live in the case though was I turned all of the values into time values, and then I can look up the buses that start and end within that certain time. So you see here I'm using the time function. So I'm going to do hour 13 minute 0, and the second one I'm going to do hour 13 minute 59. They turn up as ones as numbers, but when I convert them to the time format, you will then see that the time shows up as I want. After I put these in for all of these levels, what I can do now on this bus timetable sheet is convert the time in A, which is a 4-digit number or text value, and convert that to an Excel time value. So the hour is going to be the first 2 digits of the time, the minute's going to be the last 2 digits of the time. Now that I have the time in the case sheet and the time in the timetable sheet, I can do a COUNTIFs statement, which allows me to do 2 criteria on this time range. Basically, I'm going to look up which buses leave on or after 13 o'clock, also which buses leave on or before 13:59. Whichever buses meet both of those criteria, that's the count I'm going to get back, which in this case is going to be 19. Now for level 6, we are given an additional criteria. That is, some of the buses were stolen by the FMWC gang. So now we're asked how many buses actually departed in that hour. So I'm going to do the exact same. I'm actually going to copy my formula from the previous level to this, and because I'm using COUNTIFs, I just need to add one more criteria, which is in column D, turns up should be equal to the number 1. When I get that, now I have that 11 buses actually showed up in the 13th hour. Now we move on to level 7, which is the difficult level of this case. We have a couple things going on. Basically, what this level is asking is, let's say you get to the bus station at a certain time and you're going to a certain destination. What is the earliest that you can get to that destination? And the added wrinkle is that you are also willing to walk if an earlier bus gets you close enough, and that will get you to your final destination earlier than others. So every destination has a grid reference, and that grid reference converts into easting and northing values. Basically, so many number of meters east or north from a certain 0 point. So what I'm going to do is I am going to decode this reference into the easting and northing values according to the instructions that were given from rows 242 to 249. I'm going to do this for the first cell. Now, I will say that in the walkthrough video that FMWC UK provided after the case, they did make a mention of converting this information into a table. I think that's a good idea, considering that we're not going to be adding information. It's not going to change. It's just going to be a certain length. And so that way you don't have to always copy the formula down all of the time. So now that I have my easting and northing information, I'm going to calculate the distance from my final destination. And my final destination I am going to pull through the original case sheet. So those of you who are familiar with Excel eSports, you probably have identified that I am going to start working with a data table here. So I'm going to pull the information from example 7. I see my final destination is East Wickham. The bus station arrival time, meaning the time that I arrive at the bus station, is 10:20. I'm going to convert that into a time value again so I can make my comparisons very well. And then later what I'm going to do is I'm going to find the easting and northing for East Wickham. That will let me do my distance calculations between that and the final destination of all of the buses. So here I have the grid reference. I'm going to go ahead and convert that just like I did on the sheet before. Now, I admit I probably could have done an XLOOKUP, but instead I can just copy the formula over. That actually worked well with the absolute references. Now I'm going to take this formula for the distance and I'm going to copy it here so I have a reference. That way when I enter in my distance formula, I can just easily look at that text as I'm typing it in. So the distance formula is simply you add up the differences squared combined and take the square root of that value. That's a standard distance formula that you might see in a math or geometry class. We're going to round it to the nearest meter, so I'm going to round it to 0 digits. And now what I have here is a list of all of the distances to my destination in meters. Now when I look back at the instructions, I see that we are willing to walk up to 2,250 meters. So what I'm going to do now is I'm going to see which one of these are within a walking distance to my final destination. So an easy comparison will go out there. That'll give me true or false values. We see a whole bunch of false values on the screen, but later you will see that there are a small number of them which turned out to be true. So now that we know that some of these are walkable, what I'm doing now is I want to see how long I need to take to walk to these. There's a certain speed. It says it will take us 1 hour to walk for 3,000 meters. So I'm going to take that information and convert it to my average walking speed, which by the way is also listed in the instructions in a later row. So you see up here I'm going to take 3,000 meters over an hour. That's going to give me 50 meters per minute. So I'm going to label that there. And now I'm going to see for whichever ones are walkable, how many minutes it actually takes to walk that distance. Now you see here what I did was I multiplied by this true-false value. Remember in Excel, true equals 1, false equals 0. So what that does is if something is not walkable, it's just going to return 0. And it's going to be hard to see because I'm moving this quite quickly, but you can see that there is a sum value or a count value, which means that some of these are greater than 0. So now we have the departure time. We also have the journey duration in minutes already in the table. We can use that to calculate when the bus arrives at its destination, and then add the walking time to figure out how long it takes us to get to our final destination. So you see here, once again, doing math with time, I'm always using the time function. So I don't have to divide minutes over 60, for example, to try to do that. I'm going to keep things very simple. For the final destination, I'm going to take the arrival time, add in the walking time, if it is walkable. If it's not walkable, I am just going to leave that cell blank. So now that I have all of that figured out, what I'm going to do is I want to find out which ones are actually reachable. So I'm going to copy my table over here, except I'm going to add a filter. And the filter is going to say, show me all of the options where there is a final destination arrival time, so the length is greater than 0. And then I'm also going to add another criteria, which is the departure time is after the time that we plan to arrive at the bus station. So I'm going to convert these times into time values so it's easier for me to see. I'm going to go ahead and add that second condition in here. And now we have the list of buses. We see the first bus His bus leaves at 13:03. And now we are just going to compare this information to the example that was given to us. So we're going to check every step. The first bus leaves at 13:03. It goes to Bexley, which is a 45-minute walk of East Wickham. So the walk is 33 minutes. We arrive at 14:33, which is the answer to this question. Now, the final catch is that you have to enter your answer in HHMM format, so a 4-digit number. Now, what you may notice is that I am also going to add a sort criteria. Probably not absolutely necessary because the buses are sorted by the time they depart, but we want to know the earliest time that we arrive. So this is going to just absolutely make sure that the time listed first is the final destination arrival. Now you see here what I'm doing at the bottom is I'm going to create my formula to tell me the time as a 4-digit number. So you see I'm using a text function to convert it into a specific format. Once I do that, I'm going to run through my data table and I'm going to copy my answers over to the main sheet. However, several of these answers are wrong. Noticeably, they all equate to 0430. So I'm going to check the first one and I notice my mistake right away. You see, I copied the data table immediately below my filtered array. What that does is that if my array is especially long, like you see here, then it's not going to go through. It's going to get a spill error. When I move my data table down, now I get all the answers. We can take that and move up to the bonuses. Bonus 1, how many buses turn up? We see that the turn up column is simply ones and zeros. I just add that together, I can get it. Bonus 2, one postcode actually has 6 buses turn up throughout the day. What is the postcode? I'm going to delete my data table. It's not affecting my spreadsheet much right now, but what I'm going to do is I'm going to use a group by function. Basically, I'm going to take all of this information, group it by the postcode, and then we're going to take a look at whether they turn up or not. Now, since these are ones or zeros, I could simply use the sum function to add them together. And I see that postcode NW9 has 6 buses turn up. I'm going to go ahead and copy and paste that as my answer. Each stolen bus contains 5 tons of steel. Each telephone box contains 1 ton of steel. And each telephone box sells on the black market for 10,000 pounds. Now, it seems like a lot of math to do there, but basically, how many buses are stolen? 114, as you saw from my formula. Each bus, we're going to make 50,000 pounds of money. So I just need to multiply those two numbers together to get the answer. Bonus 4, which postcode area defined by the letters have the most buses not stolen which arrive between 10 a.m. and 2 p.m. So this was probably the trickiest question for most people because a lot of people did this question based on when the buses depart, not necessarily when they arrive. So what I'm going to do is first I'm going to create this column which is going to take my postcode and save the letters only, basically filter out all of the numbers. Now, we can't simply do a left statement or a text before. You could probably do a text before. There is a way to do that. But instead, I'm going to show you how I can do it using a concat and filter combination. So I'm going to filter out the letters only, anything that's not a number, and then concat that text together to get the postcode letters. So what I'm going to do next is I am going to refilter this list, but instead I'm going to filter for all the buses which arrive between the times of 10 a.m. and 13:59 or 1:59 p.m. So I'm going to start. I like to copy my columns over so that I can see what I'm working with in this filtered list. So I'm going to create this filter, anything that is after 10 a.m. So I'm going to use my time function to get 10 a.m. I'm going to copy that. I'm going to do the same thing, but instead with 2 p.m. So here's a list of all the buses that arrive after 10 a.m. Once again, I'm going to convert these numbers to time so I can see them. That looks good. Now I'm going to go ahead and copy this over. And I'm going to just change it ever so slightly to get the ones that arrive before or on 1:59. Now my final list should only have buses within that range. Now that I have this list, I can do a group by function, which I'm going to do over here off to the side. I'm going to group by the postcode letters. The values are going to be whether they turn up or not, ones and zeros. And once again, because they're ones and zeros, I can simply use a sum as my function. I'm going to sort them by how many turns up the most. We see that one area has 7 buses. So we're going to take that information, we're going to enter it here in the format that was requested. Final bonus, bonus 5. The song Magic Bus by The Who cited a bus fare as being 9 old pennies, or 3 3/4 pence in 1968. Given that in 2025 the bus fare is £1.75, what is the annualized inflation rate? Now, I'm sure there is a formula, an easy way to do this mathematically. I don't know it. So I am going to create this kind of list here. Basically, I'm going to take the original number, add in an example inflation rate, but I'm going to continue that all the way down to 2025. And then I'm going to do a goal seek. So what I'm going to do is I'm going to set, I want the 2025 rate to be £1.75. I'm going to do that by changing the inflation rate I have at the top. Now, when I closed that out, the inflation rate actually went back. My goal seek didn't keep. So I need to remember that when I do a goal seek, if I want the value to keep, I have to hit the OK button at the end, not the X. So I have an inflation rate of 6.97%. I am going to go ahead and type that in here, and that is going to get us the final answer for this case. You see that Excel has it showed as 7, but it is actually 6.97. If I go ahead and add some decimal places, now we get them. This was a very fun case, and I think a lot of the competitors agreed with that. Great job to Harry Watson, and great job to all of the competitors who did this one together. This case involved a lot of math, especially with time when it came to level 7, which the commentators and people agree that this was probably one of the most difficult levels. The key thing when working with time for me is to convert the numbers into actual time values. Then you don't have to worry about certain percentages or decimals, 60 over 100 for the minutes, converting time from days into minutes, all of that stuff. Using time formats just makes that much easier. Again, really fun case. This was a great solve. If you want to give it a try, I will provide a link to the FMWC UK chapter in the description. There are still a few more rounds, so feel free to sign up. You don't have to be in the UK to do so. Thanks again for taking the time to watch my channel. If you enjoy this kind of content, take a look. I've got plenty more, uploading a new video every week, and I hope to see you for the next one.
It's the Excel.